All right. Today's lesson is 1.2, variables and expressions. Okay? Jesse, read me the definition for variables on the screen. Okay. A variable is a letter that represents one or more numbers. Now, you could also say that there are occasionally symbols that represent a number. Okay? An example of a symbol that represents a number would be pi. We learned about pi last year, equals 3.14 or 22 over 7. Okay, so in all actuality, it can be most of the time, 99% of the time, it's variables, but occasionally there are some symbols that will represent a certain number. Okay, so that's the first definition. Variable expressions is our next definition. Okay, variable expressions consist of numbers, variables, and operations. Okay, when we say operations, we're talking about mathematical operations. So, as we talk about mathematical operations, okay, that word operations means adding, you need to write this down, subtracting, multiplying, or dividing. Okay, those are the four things that when we talk about operations, mathematical operations, is that we're talking about. Now, what you need to understand also about a variable expression is a variable expression can have just letters in it. Okay, I'm going to give you some examples of some variable expressions. Another word that we need to talk about just for a second is, along with this, numerical expressions. Okay, we need to know the difference between numerical expressions, which is what you have had since you were in kindergarten or first grade, and variable expressions. Okay, let me show you some examples of each. This first column, we'll put variable expressions. In the second column, we're going to put numerical expressions. Okay, variable expressions look like this. X plus 4, 3z minus 5, 4 over n plus 6, x plus y. xy plus z, okay, 4t minus 9. Those are all types of variable expressions that consist of variables, numbers, and operations. As I stated a while ago, a variable expression can have just variables. It doesn't have to have numbers to make it a variable expression. It does have to have at least one variable and one mathematical operation. Right, Brandon? Okay. Now, let's talk about numerical expressions. Numerical expressions are the expressions you've been doing since you were very young. Okay? 4 plus 5. Okay, 2 plus 2. 2 times 3. 4 divided by 2. Okay, those are all numerical expressions. The reason they're numerical expressions and not variable expressions is because why? Why would those be numerical expressions instead of variable expressions? Colton, why would those up there under the numerical expressions only be numerical but not variable expressions? What are they missing? Right, the letter, the variable. They're not variable expressions because they don't have any variables. Okay, they only have numbers. That's why they're numerical expressions. Okay, so that's the difference between the two. Okay, variable expressions, for us to do anything with them, they have to give me values associated with the variables. If they just tell me x plus 4 and they tell me what's the answer to that, I don't know. Okay, it's just x plus 4. Until they tell me what x is, I can't tell them what x plus 4 is. Once they tell me that x is equal to 5, oh, okay, then I've got 5 plus 4. Okay, so variable expressions are unknown until they give us the value of the variable. Okay, so that brings us to our next word up there on the screen. The next definition I gave you was evaluate. Evaluate is a process of substitution and simplifying. Okay, so for example, if I have x plus 4, okay, I have x plus 4, and they tell me, they want me to evaluate when x equals 22. They tell me to evaluate when x equals 22. Okay? Well, evaluate, when we're talking about variable expressions, or really anything, means I want to take that variable expression to its lowest name, or its simplest form. Okay? How we do that is this. We first of all take this 22 and plug it into my variable expression. And that gives me 22 plus 4. So to go from this variable expression, okay, here's the variable expression. Now I have a numerical expression. That is substitution. Okay, to take it from its variable form, here, x plus 4, to its numerical form of 22 plus 4 is called substitution. I substituted in the value x equal 22 into my variable expression. Now I'm going to take 22 plus 4 and get 26. So to go from here, from the 22 plus 4 to the 26, that is simplifying. Okay, that is simplifying. So we have evaluate means to substitute, and then when I've substituted in numbers, once I have my numbers in a numerical expression, then I simplify that to its lowest form, lowest name. Some people say lowest terms, simplest name, simplest form. Okay? So that's how you evaluate. So let's look at an example, a couple examples of those. I want you to turn in your books to page 11. Turn in your books to page 11. On page 11, I want you to do problem number 14, problem number 15, and problem number 16. Do those in your notes. Do those on your own from the information I just gave you. What we talked about, variables, variable expressions, and evaluate. The directions tell you to evaluate the expression for the given value of the variable. You can do it in your notes, so you're using a pen. So I want you to do 14, 15, and 16. Now, you must write the original problem. So on number 14, how you're going to write the original problem is you're just going to say x plus 14 when x equals 8. That's how you would write the original problem. Then you're going to show me plugging in the value for x, and then you're going to show me what the simplified answer is. The first one says x plus 14 when x is equal to 8. If we use the substitution principle, we substitute in 8 for the x, and we have 8 plus 14. 8 plus 14 would be 22. Okay? The next one says y minus 5 when y is equal to 13. Hopefully it's going to catch up. Shh, quiet. Okay, so you have 13 minus 5